Hello, Rohan. How are you doing?
I'm good, sir. How are you doing today?
Very good, very good. So, we had been working with quadratic equations. I thought we'll take square roots or surds or the radical expressions today. Will you like to understand what are radicals?
Yes, sir.
That'll be nice. So, I prepared a lesson for you. Let me share that with you. It's kind of very interesting. So, can you see my screen?
Yes, sir. I can see your screen.
Right. So, can you please read what is there from here? Yeah.
Okay. So uh,
Arithmetic
arithmetic
skills.
skills,
Yeah.
squares, square roots, radical expressions, simplifying surds,
Good.
express as a square root b, operations with surds, applications, mock test, and the next radical equations.
Correct. So we are actually discussing surds, and we will see how do we simplify the expressions and how do we rationalize these expressions. Now, when I say surds, what does it really mean, right? It is something like we'll actually focus more on square root. So we'll focus more on square root. Let's say we have r and we have some number n here, right? So basically it means r to the power of, we could have some m here also. We could have some m exponent here also. It means r to the power of m over n. Do you understand? That is what mean, right? So that is what that surd is. The number inside that square root thing or the radical operation is called radicand, right? It's called radicand. And this is the radical sign. That's thing like a square root thing, right? And this is the index. This is the exponent, right?
Yes, sir.
So that is how all this is, but we'll simplify our case and we'll only focus on square root today.
Okay.
Right? That is to say, as shown here, we'll just focus on square root of a number, right? So where r is called radicand and this is the radical sign. Is that clear to you? All the operations
Yes, sir.
which we are going, yeah, all the operations which we are going to do are basic arithmetic operations. We'll add them, subtract them, multiply them, divide them, rationalize them. Okay?
So, sir, it's kind of like similar to the exponent laws, like of an equation within a bracket and then that being multiplied, but instead we have the division.
Yes, yes, yes. Kind of similar, yes. And what we really need to know is squares of some numbers because square root is inverse of square, reverse of square, right? So let me just give you that concept first. So you know squares of numbers, right?
Yes, sir.
Like 1 square is 1, 2 square is 4, 3 square is 9. These are all squares of number. I will like you to remember squares of these numbers which are there on the board. I mean to say 1 square to 25 square. It is a good thing to remember.
Memorize.
Up to 10, everybody knows. 11, 121, 12, 144, many people know. 13 square is 169, and then 15 square is 225, and 25 square is 625. So these squares are actually known to most students, correct?
Yeah.
But the in-between numbers, slightly more intricate, you might have to focus and learn them. It helps in faster calculations, okay? So I'd like you to kind of put the screen right in front of you a couple of times in a day and then look at it. You will then know 14 square is 196, 16 square is 256. It is not difficult. It's like you already know up to 12, right? So 12 more to go. Is that clear to you?
Yes, sir.
So the whole idea here is that if I say, what is the square root of 36? Basically, you know 36 is 6 square, right?
Yeah.
And therefore, that should be equal to 6. So it is the reverse process. You see, get an idea. So working with radical is fun when you know the squares, correct? Otherwise, you'll have to use the calculator. And this exercise is without calculator. Many tests in which calculator is not allowed The most difficult part is to work with square roots and the radicals, because students are not used to working with square roots without a calculator. You get the idea?
Yes, sir.
So it is worth doing it. Is that clear to you?
Yeah.
Now, simple to begin with, 6 square root means it will be just 6, right? Because if you square it and then square root, it is a reverse operation, right? So we call this as an inverse operation. It really means that if I have a function here, which is, let us say, n square, right? And I'm putting input, which is n. So when I square it, what I get n square, right? So let me say
Yes.
the operation is to square it, right? Let me write square. In that case, the number, if I put n square back into this and do this operation of square root, then what you get back is number n itself. You get it?
Yes, sir.
You get the number n itself. That is how it is, right? So square of a number, if you put and do the square root, you get the number itself. So that is what it is. Even if it is a negative number, but square of negative number, you get the idea. So
Yeah.
minus 5 square will give me 5, okay? However, if I do minus 25, then this is not real number.
So squares could only be positive numbers, right,
Yeah,
sir?
so you cannot do reverse of a negative, do square root, correct?
Okay.
Because there is no number which after squaring, you get a positive number, right? When you're talking about real numbers, correct? We are leaving aside some numbers which are called complex, right? So we are not doing those. Is that clear? We are working with
Yeah.
real numbers. So in real numbers, we cannot have square root of negative number. Square root of 0 will be what?
It would just be 0, sir.
You are right. So square root of 0, because 0 square is also 0, will be 0. Now, interesting part here is, let's say we have a number 4 with the square root. It gives you a natural number 2, correct?
Yes, sir.
We call them as real numbers, correct? Real numbers are numbers which can be represented as a quotient, as a, you can say, a fraction. Is that okay?
Okay, sir.
So, but if I have square root of 2, then this is not a real. This is a real number, but not a rational number.
Rational.
Yeah. Not a rational number. Now, I have to tell you what is a rational number before getting into not a rational number. So I'm using a term here which is called irrational numbers, right? I'm calling it irrational number. Let's try to understand what are irrational numbers. Can you please read? Irrational numbers do not have repeating or
Repeating or
terminating.
terminating decimal value.
Yeah.
So they
They
cannot be
cannot be.
represented as a rational number.
So when I say rational number, it means you cannot write them over P over Q type. Do you understand?
Okay, sir.
So what I'm trying to say here is, if you divide some number, let's say 10 by 3, what do you get? You get something which
A
is
decimal.
some decimal repeating. Do you understand?
Yeah. So it's not like a whole number, sir. It's not like a
But it could be a
whole
decimal
number.
number, right? So decimal numbers, which are kind of terminating decimals. So we could have decimal numbers of different kinds. For example, if I divide 7 by 2, what do I get?
You would get 2.5, then
3.5.
3.5, sir.
So it terminates. Do you see that?
Yeah.
If I do 1 over 3, what do I get? 0.
You get 0.33.
Right?
So in infinitive.
We could also write with a bar. So this is called repeating. So we have two types of decimal numbers which we have discussed here. One is terminating, correct? And the other one is
There's a repeating.
So if we have repeating or terminating, they can be expressed in the form of P by Q, and they are therefore called rational numbers. Is that okay?
Yes, sir.
So these are rational numbers. However, if you do with your calculator square root of 2, you get a number something like this, 1.414213562. It is not repeating and it is not terminating, right? This continues, something, something, something. You get my point?
Yes, sir.
Similarly, square root of 3 and square root of 5. So most of these numbers, they do not terminate, nor do they repeat in decimal form. Is that okay?
Yeah.
So these numbers are called irrational numbers. So square root of many numbers could be irrational. So we call them all as real numbers. Do you understand now?
Yes, sir.
So real numbers include rational
Four.
and irrational numbers. Is that clear to you? So
Okay, sir.
let me say we have rational numbers. Let me make a circle here. And let me make another circle here, which is called,
Real numbers.
okay, we will call them as real numbers is outer circle, right? So let me write this
Oh.
as whole numbers, And let me make another circle here, natural numbers. And let me make one more circle. Integers. And then I will write outside rational numbers. And then after this, I will write like this. Real numbers. So today, what we are talking about is real numbers. You understand? You understand
Okay.
natural numbers, right? Natural
Yes,
numbers
sir.
are numbers from one on
One, two.
right? So natural numbers are those numbers. So if I want to put the values, it'd be like 1, 2, 3, and so on. Whole numbers will include a 0. Integers will include minus sign.
Like this.
Minus.
Yeah.
Like this, correct? Rational numbers will be of the form like this, right? Like this.
So like fractions or ratios.
Yes. So it could be all these things, right? It could be 4/5 or anything, correct? Real numbers also include numbers like square root 2. Pi is another example of a real number which you use many times, right? What is the area of a circle? Pi r squared.
3.14.
So it repeats. So if you press pi, it is not a terminating or a repeating decimal, correct?
Yes, sir.
So these are non-terminating non-repeating decimals. Does it make sense?
Yes, sir.
So like square root of 7. Is that clear to you? They are also included in this. Correct. So whenever we talk about numbers on a number line, then this number line has all real numbers. This number line represents real numbers.
Okay.
Now the question is, if square root 2 is a real number, how do I represent this on a number line? I don't know its exact value. How can I represent this on a number line? Can you tell me that?
You could use a rounded up. You could like.
No, exact value I want on a number.
Oh, without calculator, right, sir?
Yeah, calculator will give you a value which is kind of like this, right? 1.415, something like this, right?
Okay.
It doesn't make any sense to us.
So it could
Right.
be like an estimate between 2
It could be an
and
estimate.
1.
We can use Pythagorean theorem and get the exact value, and we will see how we get the exact value of all irrational numbers also. Is that okay?
Yes, sir.
So here I have written something. Exact length
exact
corresponding
length.
to the above square roots can be drawn using a set of triangles with one side of the right triangle with unit length as shown in the figure using the Pythagorean theorem. Nothing like this. If I have a right triangle whose sides are 1 and 1, then what is the hypotenuse?
It would be square root 2, sir.
Yes.
Because it'll be like 45, 45, and then that.
I mean, 1 square plus 1 square, square root will be square root 2, right? 1 plus 1 is 2. So this, we can exactly draw 1, right, at right angles. So we know the exact length of square root 2. Do we get or no?
Yes, sir.
So on a number line, I can sketch this, right? I can always take this value here and take a compass and say, well, this is my square root 2. Does it make sense?
Yeah.
So that is how I will do it. Now, if I get square root 2, in that case, again, I can draw here 1, and then I get this length, which is what? Square root 3. You see that?
Oh, because
Because,
now we're square rooting the square root, right, sir?
so yeah, so when you square root 2 square, you get 2, right? Plus 1 is 3, and square root of 3, you get the other one. You get the idea.
Right.
So on a
Yeah, sir.
number
So
line,
that one is being squared, and then afterwards they're adding it up, right, sir?
yeah, let's see it on a bigger scale, right? It's very interesting. Let me make a thicker number line, right? And let's say this is our 0, and this is 1 unit. So we can here take a compass, same amount of unit here, correct? So we'll have 1 unit on this side at right angles, correct? So that will give us this particular length, correct? And this length here can be drawn, and this length is how much? Square root of 2, correct?
Square root of 2, yeah.
Now again, what I do is at this place, I again raise 1 unit. Is that okay? And then connect
Okay,
it
sir.
here, and then draw. And what do I get?
Square root 3.
Do you see that? And then
Okay,
again,
sir.
I could actually take another 1 unit and then kind of like this, and then with the compass get square root 4, which is 2. Is that okay?
Yes, sir.
So that's a number which you can actually measure, and you'll see, well, on the number line that will correspond to exact 2 which you can measure.
So
Correct?
basically, sir, everything is the same, like in the except for like the hypotenuse, which is growing in a slant, and
Yes,
the
yes,
overall degree, it seems like it's growing smaller,
yes, yes.
but
So
more
you
longer in size.
longer. So we get this hypotenuse, which is giving you all the values, right? Radical values also, right? So this is very interesting way of getting the square root. Another way is we could actually make this kind of a thing, right? You've seen spiral shaped things like many oysters. They have this kind of a shape, you know?
Yes, sir.
So there it is a pattern, which is I've drawn here. If I take 1 unit and take the diagonal, this diagonal will be square root of 2, correct? Then again, if I draw 1 unit at right angles, I get square root of 3. Then I get square root of 4, which is 2, right?
Yeah.
And this is square root of 5. Is that clear to you? So
Yes,
you
sir.
see that A to E is a diagonal, which is a rational number. Square root
Rational.
4 is 2, right?
Yeah.
All other are irrational. However, this is 2. Is it clear?
Yes, sir.
Very interesting to see. So in this pattern also, you do get a rational number, right?
Yeah.
Now let us see, how do we work with these numbers? So radical expressions contains a radical sign. So it's just about this radical number as such. So it says that the radical expression contains a radical sign. So this is the radical sign, right? That's square root.
Yeah.
Square root, or it could be square root, cube root. If it is a cube root, we'll write like this. Right? If it is a fifth root, we'll write like this. Is it okay?
Okay. And if it were to be
Cube
squared, sir,
root.
it'd just be the same.
Yeah. Square root, we don't write anything. If I just write r, it means r to the power of half, square root.
Okay.
So we never write 2. Is that clear? So in these,
Yes.
I have not written square root. I mean 2, I have not written 2, so these are square roots, okay? The expression under the radical sign is called radicand. So whatever the number is there within square root is called radicand. Okay. Now we'll do exercises to simplify radical expression. And what does that mean? What does it mean when I say simplify radical expression? It means these three things. First, radicand should not have any perfect square factor other than 1. What I'm trying to say here is R should be not like 8, because 8 could be written as 4 times 2, correct?
Yes, sir.
4 square root is 2, so I could write this as 2 square root 2, right? So 8 is not in the simplest form, but 2 square root 2, that square root 2, it is in the simplest form. You get the idea?
Yeah.
So like a improper fraction, you understand, we divide and write 2.5 instead of 3 over 2, right? It's kind of similar
Yes.
to that. So if I have 3 over 2, I could write like what? I could divide by 2
One.
and write 1 over half, 1.5. Is that okay?
Yes,
Kind
sir.
of similar thing. So first thing, that the radicand should not have any perfect square factor other than 1. Of course, 1 will be a factor of every number, right? And 1 is a perfect square, correct? Other than 1, there should not be any perfect square factor. Radicand should not contain fractions. Inside this, we do not want fractions, right? Or
Okay, sir.
right? Radicand should not be in the denominator. We do not want, if you don't want fraction, we don't want any radicand in the denominator also. Get the idea?
Yes, sir.
So if I write 1 over square root 2, that is not simplified. I have to do rationalization to get it out of this. How do we do it?
You
We
would
can
just multiply it by square root 2 on both the numerator and denominator. So then that would just be square root 2 by 2.
Perfect.
Because square root cancel.
Perfect. So you do this kind of a thing sometimes when you work in quadratic equations and even in trigonometry, right?
Yes, sir.
But that's the whole idea, because it is not in the simplest form of a radical expression. That is why we do it. You get the idea?
Yes, sir.
Okay. So we can say that following surds are not simplified. These are not simplified because we need to do something to simplify them, right? What did we do? For example, 12, it is 4 times 3, right? So we took out 4. So it is 4 times 3, right? 12.
Yeah.
So now it is 2 square root 3, which is simplified form. When we have square root 2 over square root 3, we can multiply both by square root 3, right?
Yes, sir.
And we get square root 6 over square root 3, square root 3 becomes 3, right? Similarly, we multiply both by square root 2 and get square root 2 over 2 when we have 1 over square root 2. So we have simplified. This operation is called rationalization.
Okay, sir.
We'll look into this in details. So now we have an exercise for you. I want you to write all these surds in the simplest form. When I say simplest form, I mean I do not want any perfect square within that square root sign. Is that okay?
Okay,
So square
sir.
root 8 can be written as what? Tell me. How will you do this?
It could be written as square root 2 multiplied 4 multiplied by 2.
One
And then that would just be 2 square root 2 multiplied by 2. Or just 2.
Now tell me square root 27. How will you do this?
It would be square root of 9 multiplied by 3, which equals to square root 3. I mean 3 square root 3.
Correct. 98.
98 would be square root.
So if it is difficult, just divide by 2. It is an even number, right? So
All right, so
prime factorization.
24.
2 and 2 times what? 49, right?
40. 7.
500.
500 would be 250. I mean
5
100.
times 100.
Which would just be 10 square root 5.
128.
128 would be 64. So square root 2 multiplied by 64.
Very good job.
And then that would just be square root 8 square root 2.
Very good job. So 128 reminds me that you should also know what are powers of 2, right? What is 2 to the power of 0?
It would just be 0 and 2 to
1.
the power. Oh, and then square root 2, 4, and 6.
So do you know this pattern, right?
Yeah, sir.
2 to the power of 10 is 1024 kilo. So this is a good pattern to remember. Similarly, for 3s, at least up to 3 to the power of 5. Is that okay?
Okay, sir.
It helps. Now, this is how we simplified it. We just did it right. Now we'll do the reverse operation. That is to say, I'm giving you a square root b, right? And I
Yeah.
want you to write this as square root of c, let us say. Is that okay? How will
Okay,
you do the
sir.
reverse process? If I give you 2 square root 3, how will you write this as everything within the radical?
It would be square root of 6, sir. And then,
When 2 goes inside, it goes as a 2 square. Do you understand?
okay,
Which is 4 times
4
3.
times 3. So that's 12.
Correct.
Square
Can you
root.
do the other one?
All right, sir. So that would be square root of 9 multiplied by 7, which is square root of 63.
Correct.
Then square root of 16 multiplied by 5 equals to, and then that would be square root of 25 multiplied by 21, and that's square root of 49
And then you can
multiplied
write
by
that.
10.
Correct?
Yes, sir.
Easy exercise. Now let us see. How do we add square roots? So we'll do arithmetic operations with these radicals, okay?
Okay,
Now,
sir.
it is like apples, 5 apples and 6 apples is 11 apples, right? You can add
Yeah.
all the apples together, correct? You cannot add apples and oranges and say, well, so many apples, right? You cannot say that.
Yes, sir.
So in the radical also, we have to have same kind of radical to add. So if I have to add 2 square root 3 with 5 square root 3, I can say square root 3 is common, right? Therefore, I could add 5 and 2, right? So I could add 2 and 5 in this case with because they have square root 3 as common, right? So that becomes
Yeah.
7 square root 3. But if it is not common, it cannot be added. So that becomes a
Okay, sir.
simplified form, or that is how we add these expressions. Now, can you tell me, how will you add 3 square root 5 plus square root 20? Tell me.
I would multiply the square root 5 by 4, so we square root 3. I mean 3 square root 5 plus square root 4 point multiplied by 5 plus equal.
So you could write square root 20 as 4 times 5, and 4 square root is 2. You can simplify this, and now you can add 3 and 2 and write 5 square root 5. Is that clear to you?
Okay, so basically what happens is that if it's like a common thing, the higher number just breaks down and then they find the common.
Yeah. Whichever number you can break down, break it down. Is it okay? So next one, try next one, 500. We know
So
5.
that would be square root 100 multiplied by 5.
Correct.
Subtracted by square root 2 square root 5, which would just be is 8 square root of 5.
That is how you'll do it. Is that clear to you, right?
Yes, sir.
Try this. Square root 50 plus square root 8 plus square root 72.
That would be square root of 5 by
25 times 2 is 50, right?
yes, sir.
For a perfect square number, right? 25 is a perfect square. That's why I said initially, try to remember these squares. It helps. Do you see that? So you straight away
Yes, sir.
get, well, I should have used 25 times 2, right? So that's the whole idea. So 50 is 25 times 2. 25 is 5 square. So I could write as 5 square root 2, right? 8. 4 times 2 is 8. So I could write as 2
square root 2 square root 2 and then plus, and then square root of 72 is just 6 square root 2.
36 times 2, 36 is 6 square and 6 square root 2. So 5 plus
13
2,
square
7,
root
7
2.
plus, yeah, 36. You get the idea, right? So that is how you have to do them all. Is that clear to you?
Okay, sir.
Okay, so I'll leave this one for you to do. Multiply. Multiply is even simpler. Just as in fractions, multiply means what? If I have 2 over 3 times, let us say, 5 over 7, what do you do? Just multiply, right?
Yeah.
10 over
So it's 10
21.
by 21.
if you need to simplify, you will. So same thing, multiply outside numbers, 2 times 5 is 10, and inside numbers, 3 times 3 is 9. Do you see that?
9.
So
Yes,
then,
sir.
square root of 9 is 3, right?
Yeah.
So you get 30 here. Is that clear to you? So you see that square root of a times square root of a is what? Square root of a square, and which should be equal to a. Is that clear to you?
Okay, sir.
That is very important. It is always positive. It is always positive, right? So we normally write it always positive or absolute value. Always positive. Is that clear to you?
Yes, sir.
Okay. So if I have to do 14 times square root 28, how will I do this? Can you tell me now?
It would be, so both of them are similar, so it would just be square root.
So 14 times 28 can be written as 14 times 2.
14 times 2. Yes, sir.
Now we have 14 square root 2. Do you see? Sometimes we could do like this. Because 28 has a 14 factor. 14 will get 14 square, and we can now take it out. So that is also a technique to simplify. Is that clear?
Yes, sir.
Next one. 50
So that
times
would be,
square root 8.
so 25 square root 2
Correct.
multiplied by 2 square root, 2 multiplied by 2 square root 2, so that would just be 10 multiplied by 4.
Which is 2, right? So you get
Yeah.
5 times 2, 10, 10 times 2, 20, and these things is also 2, right? So you get 40.
Yeah.
The idea?
Okay, sir.
So that is how you could do it. Does it make sense to you now? Next
Yes,
one,
sir.
try this out. 24
So
times 12 times 27. How will you do this?
it would be 3, so 2 multiplied by 12 multiplied by 12.
So I could see 24 as 2 times 12. I already have a 12, right? So I made it 2 times 12. Do you see that?
Okay, sir.
Does it make sense?
Yeah.
So now I got 12 outside, and this 9 will give me 3 outside, right? So 12 times 9 will give me 3, and inside I have 6. You see that?
Yes, sir.
So this will be 12 times 3 square root 6, which is 36 square root 6, right?
Okay, sir.
So sometimes it could be tricky, but you could use your strategies to multiply and divide. So I've given you examples which are very helpful to understand different strategies to multiply, correct?
Yeah, okay, sir.
So this is your test question, okay? Practice it later. Now let's look into distributive property. So we'll actually post this video, then you can do all these questions yourself, okay?
Okay.
Distributive property is very similar to what you have learned earlier. That is, A times B plus C is what? Is equals to A times B plus A
B
times.
plus AC.
So you have to multiply A with both the terms and write it down. Same thing we'll do here, right? We know now both operations, addition and multiplication. And so we could easily do. So 2 square root 3 times square root 12 plus square root 6 is how much? First you multiply this, you get 2 square root of 36, correct? Plus 2. Outside is 1, right?
Yeah.
And this goes 18. Is it okay? 6 times 3 is 18, correct? Now 2 times 6 plus 2 times, this is 9 and 2, right? 9 and
Yeah.
2. So this is 12 plus 9 outside is 3, right? So you can write this as 12 plus 6 square root 6. Is that clear to you? That is how you
Okay,
can do
sir.
it. Can you help me do the next one, please?
So it would just be A plus B in one bracket and C plus C. So A to one
So 5
side and
times
then
5 is 25. First square
25
is 5.
minus square root 10.
5 square root 2.
5 square. And then
5 square
plus
root 2.
5 square root 2.
Yeah, 5 square root 2. Let's write 5. You're right. 5 square root 2.
And then
Minus 2. Is it okay?
minus 2.
Yeah. So 25 minus 2 is 23.
23.
And this is minus 5 and plus 5 is 0. Is that okay? So you get a number
Yes.
23. Do you see that?
Okay, sir.
So this is the same as what is A plus B times A minus B equals to? It is A square minus B square, right? So we did get A square minus B square, which is 25 square minus square root 2 square is 2.
Square.
You get the idea?
Okay, sir. Yes, sir.
We get 25 minus square root 2 square. Is it okay?
Yeah, okay,
Which
sir.
is 23. Right. Now, you remember the formula for perfect squares? What is a plus b square equals to?
A plus b square would be a square plus b square. I mean,
Plus 2ab.
no, 2ab plus b square.
And if this is minus, in that case, this is minus, right?
Yeah,
So let's do this. What is 5 minus square root 3 whole square equals to?
it would be 5 square, so 25 minus square root 3, so not 3.
Is that clear?
Okay, sir, because
apply
the
the formula.
2ab is added, right?
Yeah. 2ab plus 3 square, square root 3, 3, right? So 25 plus 3 is 28, right? Minus 10 square root 3. Is that
Okay,
clear?
sir. Yes, sir.
Next one here, can you tell me what will it be? Square
So
root x
that
plus
would
6, yeah.
be square root, so square root x squared plus 2 square root x square root y, and then plus y square root 2. So x plus.
Clear?
Yes, sir.
Very good. So we have seen how do we add, how do we multiply, and distributive property. Now let's work with these expressions. Most of the operations now will be like multiplication and division both involved. Okay. We need to simplify expression. Remember, simplify really means that in the denominator, you cannot have radical. You will have to rationalize. Is that okay? That is the whole exercise.
Yes, sir.
So how do we do this? 27 times 18 times divide by 96. 96 is 49. So this is square root 27, as you know, is 3 square root 3,
9
right?
3 square. Yeah,
Times 18 is 9 times 2.
9 times 2, so 3 square root 2.
49 times,
Divided by
this is what? 28 is square root 2 divided by 48, right? Doesn't work.
48. Yeah.
96, how will you write?
So 96 would be 40.
4 times 2 is 8, 24, right?
24. Yes, sir.
So 4 times 24. Now, 24, does it have any perfect square within itself as is, right? No, right?
No.
You can have 4 times 6, right?
Yeah.
So there are 2 4s outside. So we'll get one of them out. Do you see that?
Yeah, so then it'll be 2 and 2,
4
3.
square root 6. Is that okay?
Okay, sir.
You get the idea? We'll write
Yes,
square root 96 as 4 times 4 times 6. 4 times 4. We'll take one of the 4s outside. We're left with 6 here. Does it make sense to you?
Yes, sir.
And now, square root 3 times square root 2 is square root 6, right? And 3 times 3 is 9. So let me write 9 over square 4
6,
square root.
and then divide by 4 square root 6. And then it would just be 9 by 4, sir.
Yes. You get the idea how to do it, correct?
Yes, sir.
So likewise, you do this one as an exercise, okay?
Okay, sir.
Now, it's slightly more complicated. Now we'll add, right? Add with different denominators, right? As it becomes complicated in fractions also when you have to add with different denominators, right? Okay, so let's do the first one. How do we do? 2 square root 63 over square root 15. So I could write this as 2 times 63 is what? 9 times 7.
9 times 7.
Which is 3 square root 7, right? We are cutting down on steps. Over
Okay.
15, we don't know. 5 times 3.
So 3 square root 5 or 5 square root 3.
Square root 15 itself, right? Nothing common.
Okay.
42. 42, can we break it up?
It can be broken down into 21.
Which doesn't help, right?
Yes,
21 and 2, nothing, right? So, well, you may write 21 and 2, but doesn't really help, right? 10, square root 24, you know, is 4
it
times.
can be broken down to 4 and 6.
Well, we got all this, right? So, common denominator is what for us?
2.
So, what is the common denominator? This is 20 square root 6, right? This is 20 square root 6, right?
Yeah, sir.
So we get here 6 square root 7 over square root 15 plus. This gives us, well, that doesn't really help, but can we cancel something? We'll bring this away. We get square root 21 here, but we could cancel this 2 with 6, right? We get 3. Do you see that?
Where is the 3, sir?
6 divided by 2.
6 divided. Okay, sir. Yeah, I see.
You get the idea? Bringing
Okay.
2 outside, we get 20 square root 3. That does it make sense?
Yes, sir.
Now the common denominator could be 20 square root 15. So we'll have to multiply this with 20, right? So we get 20 times 6 times square root 7 plus. We'll multiply this by
5.
5 square root, right? So 21 times 5. Is it okay?
Okay, sir.
So that is what our answer is going to be. So it becomes complicated when you work with such expressions in general. You get the idea, right?
Yes, sir.
So now you have to do this yourself. Remember, it could be complicated, right? But this is simpler because we have square root 2 and you understand now this, right? Square root 2 over square root 6 means square root 2
Square root 2
square root 3 times square root 3, right? So they can
Yes, sir.
1 over square root 3. Is that clear to you? So
Yes,
this can
sir.
be simplified. Is it okay? Even
Okay,
this
sir.
can be simplified because they have a common factor 5, correct?
Yeah.
So this could
And
be
then
written
would
as,
that like 1 divided by square root 3, sir? Wouldn't that become just square root 3 by 3, sir?
yeah. So this is easy. Do you see that?
Yes, sir.
So now you could take square root 3 as common denominator and you can add these two terms, right? 2 square root 2 plus 3. Is it okay?
Okay, sir.
So in the last example, we have to also rationalize it. So that is another thing which we need to do, but we are leaving it here, okay? Rationalize, we'll learn how to do rationalization. So there's a lot of things which we have covered so far. We are trying to go fast because I know you can practice and get all these concepts soon, right?
Yes, sir.
Also, I'll share with you my playlist. So you can go through the playlist and learn them more. So let's practice with subtraction this time. So let's do this one. This seems to be easy. Let's try to do this. Can you help me doing this?
So it's square root 27 by square root 15 subtracted by square root 24 divided by 2 square root 30, sir. So wait, we're doing which one, A or B?
B.
Oh, B, sorry. So 2 square root 8 divided by square root 50 minus 3 square root 2 divided by 10. So that would just be 2 multiplied by 2 square root 2 divided by 5 square root 2. So wouldn't that just be 4 by 5 on one side?
Yes.
Subtracted by 3 square root
2 over 10.
5,
10
sir.
is the common denominator, yeah?
So would it be 3 by 5? So 4 by 5 minus 3 by 5? Or, I mean, 3 square root 5?
This is 2.
Okay.
That is all, right? You see that? So we take 10 as a common denominator and simplify it, correct?
Okay.
So that is how you could do it, right?
Yeah.
In this case, you could simplify this part and you'll get square root 15 in both, and then it can help you to do it, correct? So you have square root 27 over, let's keep 15 inside. We can minus. If I divide by 2, I can write square root of 12 over 2 square root 15, correct? So I got 15
Yes.
within the square root common, right? And then I can multiply this by 2 square 27. I mean, I could simplify this. I'll do it later. Don't worry. I know this is wrong. So it is always 27 can be written as 3 square root this, right? 2 times 3 square root 3. Let me write it. And this is 12, which is 4, 2 square root 3. Is it clear? So
Yes,
we can say 6 minus 2 is 4, 4 square root 3 over 2 square root 15, right? Now,
Yeah.
15 can go. This is 2. And over square root of 5. Is that clear?
Yes, sir.
And now
So
you can
would
rationalize.
that be square root 10 over
So 2 square root 5 over 5. Is it okay?
5? Okay,
That
sir.
will be your answer. So this is your final answer. Is this clear to you?
Yes, sir.
So we have done rationalization, and now let us have a question for you for rationalization. Can you do rationalization of all these? 1 over square
I
root 2
assume,
first.
sir. I am assuming that I can.
Yeah, tell.
So for a 1 by square root 2 would just be square root 2 by 2, sir.
So basically, you'll multiply by square root 2 over square root 2, which is 1, right? So it doesn't really change the equation. So it's a square root 2 over 2. Next one.
So 5 by 2 square root 3, it would just be square root 3 divided by square root 3. So that would just be 5 square root 3 divided by 2, I mean 6. Sir.
Correct. Next one, how will you do?
So in that one, it would just be 4 divided by 2 plus square root 3. So that would be multiplied by square root 3.
No,
I
we
mean,
multiply by
minus.
the conjugate, 2 minus square root 3. This is important, right? So you multiply and divide by conjugate. Why? You know, a plus b times a minus b is what?
It would just be a square minus b square.
So you'll remove the radical sign. Do you get the idea? So this is
Okay,
called
sir.
conjugate. So if you multiply by conjugate, both multiply and divide, then you remove the radical sign. So here you get 4 times 2 square root 3, right? You get 4 times 2 minus square root 3 in the numerator. And the denominator is 2 square, which is 4, minus 3. Do you see that? So you get 4
Yes, sir.
times, you can 2 minus square root 3 is your answer. You see that? If you want, you can write 8 minus 4 square root 3 as your answer. You get an idea.
Yes, sir.
That is how you are going to do this particular question.
Okay.
Now, let's look into application questions. How do we apply these square root things in many questions? You have been doing all this, nothing new. But now you have the concept, you have the groundwork done, foundation, correct? Can you please read this question and then solve?
Find the length of the longest diagonal in a cube with each side length of 10 centimeters.
Yes. How will you do it?
So
A,
we
B,
have
C,
to
D, F.
find angle theta, sir.
No, no angle theta. You have to find this diagonal length from A to G. This is your longest diagonal, right?
Okay, sir.
How will you find? You know length, width, and height of this is 10, right? So length, width,
Yeah.
and height is 10. How will you do this?
So, and I need to find the distance from A to G, right, sir? Or A
Yes.
to D?
You have to find the distance from A to G. Yes.
A to G, okay. So what I would do is I would multiply, I'll do volume and then I'll divide it by half, sir. That way I
No,
can.
no. So you find the diagonal in the base first using Pythagorean theorem, which is A to C, right?
Yeah.
A to C is 10 square plus 10 square square root, right? Pythagorean theorem, which basically is 10 outside square root 2, right? Do you understand?
Yes, sir.
And now you can use A to G as square of 10 square root 2 plus 10 square, right?
Okay.
So that is
So
what?
that that would just be 10 square root of 3.
Because this will be 200, right?
Yeah.
Correct?
Yeah.
So in a cube, you can say in a cube it is a square plus b square plus c square square root. Because this side is a square plus b square, right?
Okay, sir.
And then that is c. So it is, this will be the formula directly. You can apply this and get the maximum length of the diagonal from one vertex to the right diagonal opposite, right? Do you get an idea how do we solve such questions, right?
Yes, sir.
Now that becomes your test. We learned all these concepts today. So here is the mock test for you. All these questions you can try after the class, right? So let me just, you can pause the video at this stage. Do these questions one by one. We have learned everything. We have learned how do we simplify the expressions, correct? How do we simplify using distributive property, right? What are perfect
Yeah.
squares? We've done these examples similar to these, correct? adding, subtracting, all these things. I like you to do this. And if there's any difficulty, you should let me know. Okay.
Okay.
And here's the last question for you, which is again simplifying but using division. Important thing here is division means multiplication, right? So
Multiple.
this
Yeah.
particular question, what it is basically square root of 18 over square root of 28 times what?
Multiplied
2
by
square root
square
square
root
over
divided by
square root
square root
63.
63.
Because division is reciprocal of multiplication, correct?
So the reverse of numerator and denominator between
Yes.
the second equation.
You can easily simplify it. And this example is very similar to what we did, correct? And then
Okay,
the
sir.
last example involves rationalization, which is very difficult. Do you see that? So try them out.
Yes, sir.
Try them out. So that will give you very good practice. Once you've done this, you can share your solutions with me. In case there is any difficulty, let me know. Okay?
Okay.
So that becomes a complete chapter in itself. So can you summarize what did you learn today?
So overall, in today's class, I was able to understand and look at how the square root a square root b can be expressed in multiplication, addition, subtraction, and addition, along with looking at word problems in, for an example, like the cube problem of distance a to g. And I was also able to look at how we could solve these complex equations.
Correct. So, and this is going to help you in many places, especially quadratic equations, because every time you have to work with this square root and trigonometry. So you're beginning to learn trigonometry, right? You're in between wanting to find that angle theta, right? In
Yes, sir.
trigonometry, right angle triangles, we're always working. And as you can see, the hypotenuse is normally a radical. It's a real number, right? Some radical
Yeah.
square root is there. So we have to work with these radical expressions a lot, especially in trigonometry and quadratic equations. So that will give you a good foundation. Perfect.
Okay, sir.
So here we are going to end, but watch my video once again and try to do the mock test and those application questions. Okay.
All right.
Okay. Bye then. All the best.
All right. Goodbye, sir. Have a great day.
You too. Thank you.